So let's look at an example where we have to identify, based on some information that we're given, the observational unit, what the variable is, the population, sample, parameter, and the statistic. So number one, according to a Gallup poll that was done on September 1st, 2019, of a random sample of 1,525 US adults, 62% support banning smoking in all public places. Now, we're asked to identify the following. Now, first of all, when I think about observational unit, you can think about, some people find it easier to think about the variable first, some people the observational unit first. You choose whichever one makes sense for you. When I think observational unit, let's start with that. I think about, okay, I'm going to look at each of something. What am I recording information on? Who am I recording, in this case, information on? Well, we see that we have a sample of 1,525 people. It looks like we asked them whether they support banning in all public places. So the observational unit in this case is each US adult. What varies from US adult to US adult? Well, a lot of things do, but what did we focus on in this poll? Well, we focused on, take a moment, see if you can come up with it. And hopefully you're thinking, well, whether the support banning smoking in all public places. So what's going to vary from US adult to US adult? They were probably asked a question like, do you support banning smoking in all public places? We don't have the exact research, what the research question is, but we can infer based on what we see here in the results. Now, it doesn't specifically ask, but let's identify whether this is a categorical or quantitative variable. Well, let's see. Whether support banning smoking in all public places. Well, either you do or you don't. We assume that there are just the two options, that there's no opinion is not an option unless you're specifically told. So this would be categorical in nature. There's no numbers there to think about, well, there's no numbers to average that would make sense. Is it binary or is it not? Well, there's two options, either support or don't support. So I would also say that that is categorical and it's binary. The population. While for observational unit, we have the word each. For population, we use the word all because we're actually interested in all of something. We looked at each US adult in the sample, 1,525, but who do you think the big number is what do you think the big population is we're interested in? Well, hopefully you think these two should be related. If we're looking at each individual adult, each US adult, when we do this, we're interested in all US adults is our population that we drew those 1,525 US adults from. You may be like, why couldn't I just say each adult? Why do I need US? Well, US views smoking differently than a lot of other countries do. And if they took a sample based on just specifically US adults, we can't say anything about how they feel about smoking, for instance, in France. What is the sample? Well, the sample, we're told to us, is 1,525 US adults. If I asked sample size, the sample size would be 1,525. But when you're asked for the sample, we want more than just a number. Now, parameter and statistic. Remember, the population is related to the parameter and the sample is related to the statistic. The population, we don't know what that value is. We don't know what that proportion would be, or that percent. If you go back and you look earlier, we'll see that that is P. And the statistic will be P hat. These have to correspond in the sense that they both have to be related to categorical data, because we saw that, oh, it's categorical in nature. Now, do we have a number? No, we don't have a parameter number, so we're going to describe it in words. The parameter, P, that we're interested in hopefully making an estimate of is the proportion of, remember, the parameter is related to the population, the proportion of all US adults Who what? Who support banning smoking in all public places. Now, the statistic, we actually do have a number. Remember, this 62% was calculated based on what we found in that sample of 1,525 US adults. So the p hat is 0.62. Can we actually, though, still describe it in words? Sure. This is going to be the proportion. I'm going to do that prop period just to keep it a little shorter of the 1,525 US adults who, and I'll just say who support, and then dot, dot, dot. The same thing is right above, who support banning smoking in all public places. So here, remember, this numeric value is going to be unknown. We won't know that. This is an unknown value. We may make an estimate of what it is, but we don't know the true value of that proportion. If the only way to know that true value would be to ask every single US adult. Well, we obviously can't do that. So what we're going to do is hopefully infer something based on the statistic back to the population, from the sample to the population. Hopefully we'll be able to say something, the statistic, about the value of the parameter. Number 2. So this is another, we've gotten some results. Here, this is a poll, it looks like. Pew Research Center has a report that based on a random sample of 2,422 rural US adults, the average time to the nearest hospital is 17 minutes, and that's adjusted for local traffic patterns. Please take a moment, pause the video, and work it out. Even on a piece of scratch paper, work out what these, the observational unit, the variable, population, etc. are. And when you're done, please restart the recording. So let's briefly go through this. Hopefully you took a look through, spent a moment actually, working it through. Remember, when we're looking at observational unit, we're looking at each versus the population, we're looking at all. So the observational unit in this case is each rural US adult. Why couldn't we just say each US adult? Well, traffic patterns are very, very different, and the number of hospitals are extremely different. I grew up in a very rural area, and the closest hospital when I was growing up was 15 minutes away. However, that hospital ended up closing, and then the closest one was in good weather, 25 minutes. A lot of rural adults do not have easy access to a hospital, versus if you're in a major city, usually you can see them. There are quite a few of them. The time, the variable, the time per person to the nearest hospital, or the time per rural adult to the nearest hospital. And that's quantitative in nature, because remember, we can take all those times, add them together, and divide by in this case, the 2,422. The population that we're interested in are all rural US adults. That's who we're interested in studying and finding out information from. The sample, 2,422 US, I should have put the word rural here, I apologize. 2,422 rural US adults, because remember, we're looking at, I just got on a roll there. We're looking at rural US adults, mu, because we're looking at a quantitative variable. So mu and x bar are the symbols that are related to it. That type of variable. Mu is the average time for all rural US adults to the nearest hospital. We don't know what that time is, okay? But we did find a statistic, x bar, and it being 17 minutes. Now, I wrote out average time for 2,422 rural US adults to the nearest hospital. So I will ask very clearly, for statistics, you could say x bar equals 17 minutes. If I ask you to describe it in words, this is what you would add on. But for the parameter, you're pretty much always going to need to use words because you're not going to have a value for that parameter. In this way, you're very clear on what you're looking at. Remember, these two are related. These two are related. Hopefully the population is the big one. The sample is taken from there. The parameter is what we want to estimate, mu, and hopefully we're going to be able to draw some inferences about mu based on this little sample and the value that we get from it being x bar.